This video is going to be about how to do your problem and analysis, and we're going to base it on this data here. We've already had the graph chosen in your actual assessment. You will have to choose what groups you want to compare. This one's females and males. You might choose different ages or something else, whatever you can do for the data set. And this one's comparing the marathon time in minutes. Alright, first thing we're going to do, I'm going to fill in my worksheets. This is my Worder. And now I'm going to do my problem. So I've got to be something that I can answer from this that I've got. Alright, I'm thinking I might do something along the lines of this one. I wonder if females tend to, I've underlined tend to because it's not necessarily means all the time, take longer to run a marathon compared to the males based on a sample from marathons within New Zealand. So it's a sample of marathons. I should have put, I still can, from a sample of marathons within New Zealand. Yeah, this is pretty much it. I've got two groups, females and males. I've got my ER word, like longer to complete a marathon. So this is measured in minutes. So pretty much all I really need for the problem. Next, we're going to have a look at a few of these. Shape. Well, shape, there's a few different things we could have for shape. The main three types of things that I'll be looking at. There are a few others, but basically symmetrical or bell-shaped. This curve here, you would be probably the most common. You'd have, if you're looking at heights, for example, you'd have most people around an average height. Some people are freakishly tall and some people are freakishly short, but this is sort of a symmetrical or a bell-shaped curve distribution, and you'd normally look at the dot plot to get this. You could have skewed right, where all the data is here on the left. It's called skewed right because you're skewing the mean further to the right compared to where the middle should be. And there's skewed left, again, all the data is on the right, but skewed left because you're skewing these smaller values are skewing the mean further to the left than what it actually probably should be. So looking at the data that we had this graph. I would say that looks fairly symmetrical, but that's a little bit skewed to the right. There's a little bit more data on the left-hand side, so a little bit more so. I would go as far to say it's very subtle, but a little bit of a skew to the right. And I'm going to write about that under my analysis. Alright, I would have put it quite a bit here in for the shape because I was sort of looking at it sort of an attempt for excellence. So when I look at the dot plot, just to tell you where I got my information from, I think the data is slightly skewed to the right for both the male and female marathon runners, although the female one looks more skewed. So in this, I'm just going to point out I have to compare both male and female, so not just talking about one of the data sets and doing a comparison. And I'm going to try and justify it. So this could be just, because this is just a sample, could be a result of sample variation. Maybe if I took another sample, it wouldn't be so skewed. Maybe this is not considered skewed at the moment. But I think it might happen because if a runner has a bad run, slight injury or stomach upset on the day, then it would give a slower run than usual. And I think that's why you have this, particularly you can see it in the females, the tail's a little bit longer than the front end. There's one way in the front, but the tail does look a little bit longer here. This one that seems to have a few more a little bit back. Maybe they just had a bad run. At level 1, you don't have to link that to the research or anything. Alright, moving on. Middle 50%. I'm basically just going to tell you where the middle 50% is. I'll talk about it more when I get to the spread. Alright, so middle 50%, I might put something along these lines. It should be a simple enough statement. The middle 50% is between that and the males, for the females, whereas the males is between those many minutes. I just simply read so that 232.5 minutes for the females is this value up here, 232.5. So it's between the lower quartile and the upper quartile. So this is the middle 50%, 25% in this box, and 25% in that box. Same with these guys. The lower quartile's there, the upper quartile's there, and I just set the numbers that it's between. I'll go into more detail later. And I do like to see units there. Units, I don't know, just they're just meant to be there all the time. Alright, overlap. Overlap, we're going to talk about how much these boxes overlap. And it could depend a little bit on how much data you have as to how much you talk about it. But these are sort of examples of overlap. These boxes are, you can just rotate them 90 degrees. They're sometimes drawn this way. Sorry about this line over here, that's not normally there. You can't really see with my pointer. Can I get a better pointer? Read. It's tiny though. Anyhow, you got this line here, but anyway, we'll continue. So this one here, this box, when I'm talking about overlap, I'm comparing that box with this box again. And this bit's only got a little bit of overlap. There's only from here, I draw. Yep, there's only from here and there that is overlapped between the two. This one's quite a bit of overlap. B's pretty close to all overlapped compared to A. So this one you'd say a lot of overlap. This one you'd say a little bit of overlap. This one you would say no overlap. No. And yeah, let's see how ours looks. This one's got quite a bit of overlap if I look. This one's yeah, I would say quite a bit. We're going to go into a little bit more detail with that when we start getting to trying to make a call or not. But for the time being, you can say there's quite a bit of overlap. That would look like, I'll put that down here. I've just put here the box for the male marathon runners has quite a bit of overlap with the box of the female marathon runners. So it's using some terms like quite a bit. We could put some numbers to it, but that's actually not what this assessment is about. This assessment is trying to get a visual idea of how the data looks. So quite a bit's alright for this standard. Alright, now we're going to look at the spread. And I'm going to actually combine these. I'm going to go to the extreme example of just deleting interesting features, because I sort of see anything interesting is usually something that's unusual. So I'll keep those the same. But spread, I'm going to compare the middle 50%. I'm sort of just going to continue this exact sentence. I'm going to move this down to here. And I'm going to talk about which one's more spread out. I'm going to look at the box. Oh, they're pretty similar. I'd say that this one's probably a little bit more spread out than the males, a little bit more spread out than the females, but there's not much in it. I'm going to get a bigger number when I do my minus, the upper quartile minus the lower quartile, which is the interquartile range. But it's not that much difference, and it could just be because of sample variation. So let's see what that looks like. So here I've just added a little bit more to this first bit that we wrote at the start. So this time I've done the interquartile range, which is the spread of the distance between the upper quartile and the lower quartile, so that minus that. I've got that. You can see that's a little bit smaller than this, which means that the males is a little bit more spread out than the females. So the male data is more spread out than the females runners. But when I look at my box plot, I can see there's not much difference. There's not too much difference between those two numbers. Maybe about 10%, a bit more. In reality, I see no reason why the data would be more spread out. I think it would be just a result of sample variation. As I see it has shifted further up scale. For unusual, if there's any questions, I don't know, I'm sure you'll figure it out. Just watch a video again. For unusual, I don't know if I see anything too unusual. There's this little, maybe considered an outlier here. Maybe that one at the front. Some fast lady. Some a little bit slower. but nothing too spectacular. I'll probably go ahead and say you only really need 3. You should aim for 3. I could probably talk about something called shift as well. This data looks pretty close to the same. It's just been shifted further up the scale. The female data has all just been shifted further up the scale than the males. I'm just gonna skip unusual features for this one. Oops. And right, nothing to see here. Mostly because I'm a bit lazy and this video is pushing 10 minutes now. And yeah, I'm going to leave you to it. Good luck.